When it comes to combining like terms, there are three things you should remember. One, when combining like terms, do not mess with the exponents. Leave them as they are. Number two, if all the bases are different, and the bases are usually exponents, then you cannot combine like terms at all. And the last thing, if all the exponents are different, you still cannot combine like terms. How? So let's do some examples. So example number one, you have this big old long expression. So let's combine it. Based on those three things, the first thing you should do is make sure that all the variables are same. In this case, all of them happen to be a c. And if you notice, they all have different exponents. Some have 4, 5, 6. So we're gonna have to figure out which ones have the exact same exponents. So because they all have bases of c's, let's just focus on the exponent. So the first thing, we have fourth power right there. We also have fourth power right there. So we can combine them two easily. So those two, we can combine them as -3 plus 7. Combine the coefficients. Leave the exponents alone. Just take the coefficients and combine them. So -3 plus 7, that'll give you +4. And like I said earlier, leave the exponents exactly as they are. So the 4 remains as a 4. Now let's see if you have other pairs that match up completely. Well, we have c to the fifth right here and c to the fifth right there. So yes, go ahead and combine those two. You combine them by taking the coefficients, which are -4 and -9, and simply add them up. So -4 and -9, if you add them up, you get minus 13c to the fifth power. Again, the exponents, do not mess with it. And the last thing, all you have left over is c to the sixth, because that's the only remaining c to the sixth. There's nothing you can do about it. It's going to basically tag along at the end, like so. So that's pretty much the end of it. Next, look at this one. It has a bunch of letters, different letters, C's and D's, and they seem to have basically same exponents. Some have two, some have single power, but we're gonna have to figure out which one is common. So because they all have C's and D's, so let's focus on the exponents. Well, the first one has c to the first power. Well, which other one has c to the first power? That has c to the second, so that's not a like term. That's c to the first, so that's a like term. Because c to the first match up with this c to the first, let's focus on the d's now. Well, this one has d squared, if you notice right there, and so does this. So they both have c to the first, d to the second. That means that this can be combined with this. They have the same letters with the same exponents on top of those letters. So take the coefficients, which are 4 and 7, and simply add them up. So 4 plus 7, that'll give you 11. And like I said earlier, leave the c to the first alone and d squared alone as they are. Now let's see if we have other pairs. Well, this one has c to the second, and so does this. But then this one has d squared, and this one has d to the first power only. So those two are not common. And the last one has no squares at all. So unfortunately, that is the only pair, only term that has c to the second and d to the second. So you're going to keep them as they are, like so. So that cannot be combined with anything else. And then we are left with c second and d to the first. Well, this one and this one, if you look at the last two, they have nothing in common. Yes, they both have c and d's, but the exponent on the c are different. This one has a square, if you notice, and this one has first power. So they're not the same. Even though they both have d to the first, that becomes irrelevant because the c's are different. So just again, if the c's are different, even though these have same exponents, the d's won't matter, and the c's won't matter in this case either because they have different exponents. So you're going to keep them exactly as they are. So the 5c to the second to the first, and then plus 8c to the first, d to the first. So that's all you can do with that one. Only one thing can be combined. The rest of them cannot be combined. Next example, in this case, if you notice, all the letters Every single letter is different. All the variables are different. So even though they have the same exponents, that's irrelevant because all the letters, all the variables, all the bases, as they call it, all the bases are different. So A, B, C, D, and E are all bases, and every single one of them, if you notice, is a different letter, different variable. So in this case, that's all you can do. This cannot be combined any further. So I would just state cannot be combined any further. It's going to stay exactly as it is. So next question, you have all the C's. So bases are all the C's. Bases are same. They have all C's as the basis, but the exponents are different. Every single C has a different exponent. So in this case, this cannot be combined any further either. So I would simply state cannot be combined. So that's the end of it. I would just circle that, call that the answer. Nothing you can do about that any further. So that's pretty much the gist of combined like terms.